Hey guys, we are going to be talking today about enzymes. So we are building on some stuff that we've already talked about proteins. So enzymes are one of those categories of examples of a protein. So we're going to be talking more specifically about them today because they are super, super important to you and your functioning systems in your body. So anywhere where you see that it's highlighted, the words might be in pink or in orange. That is definitely something you would want to write down. And the other stuff, paraphrase or whatever it is that you would like to do. So we are going into Enzyme Notes right now. And the essential question for this that you would want to put at the beginning of your notes is, what are enzymes made of? And what affects their function. So you need to know by the end of this notes video what enzymes are made of and what affects their function, what changes what they can do. All right, so the first part of this is just a little bit of background on cell chemistry. Every biology reaction or biological reaction requires energy. You can't get something for nothing. So whatever we need to do, we need to digest, we need to move a muscle, we need to do anything like that is going to require energy to do it, okay? And there's a specific type of energy when we're talking about enzymes called activation energy. So you really need to know that vocabulary term, activation energy, and it's the energy that is required to start a reaction. So it's a type of energy that you need to activate a reaction. And it depends on the reaction in question on how much or whatever you're going to need. So again, activation energy is the energy required to start a reaction. So before the reaction can even start, you already need an input of activation energy. Increasing the temperature of something is the easiest way to increase the reaction speed. So if we're looking at reactions in general, if we up the temperature, then usually reactions will go faster. But reactions have a certain rate that they usually go at, and this is why we need enzymes. All right, so some definitions here. You can just type these down. If you need to pause right now, you can. A substrate is a material on which an enzyme acts. So you have an enzyme and a substrate, and the enzyme is going to attach to the substrate and act on that particular substrate, okay? Products are the end materials that you get out of a reaction with an enzyme. Reactants are the things that start a reaction. So you have two separate reactants, okay, and then a reaction goes, and then you come up with products at the end. And specificity means that enzymes can only work with specific substances. So one enzyme does a specific job, and it doesn't do the same job as another enzyme. They are specific to certain substances. If we're looking at reactions, okay, and you have this graph right here of energy versus time. So the amount of energy used for the time it would take for that reaction to run. If you have an enzyme being used as a catalyst, okay, this word catalyzed or catalyst means that an enzyme is used to make something go faster. Okay, so an enzyme acts as a catalyst. It acts as a substance that's going to make a reaction go faster. If you were going to have a catalyzed reaction, an enzyme basically lowers the activation energy needed to make that reaction happen. So let's say I need the energy to move my muscles to start running. Okay, I want to start running. I need a certain amount of energy available, activation energy, to get that process started. And let's say it's that blue line. If I didn't use an enzyme, I would need this much energy, okay? That is an uncatalyzed reaction, a normal reaction not acted on by an enzyme. It's going to take me this much energy, this blue line up here, okay, in order to get that reaction to start running happening. If I use an enzyme as a catalyst, something that's going to make it go faster, what it does is that enzyme lowers the amount of activation energy I need to drive that reaction. So if I need this much energy to start running without an enzyme, if I add an enzyme in, it lowers the activation energy I need so that I can get that reaction done faster. I don't have to accumulate all that energy, okay? So you're using less activation energy for a reaction. It lowers it. All right, this second part about enzymes, if prior to, we said that usually if you raise the temperature, it will make a reaction go faster. That's not always possible. If you want your reactions in your body to go faster, Does it make sense to say, well, that's fine, go ahead and raise your core body temperature to 105 degrees? Probably not, okay? That is not a feasible reaction for you, because that will make you sick or you could possibly die. So instead of raising the temperature when it's not possible, enzymes can provide the change as that catalyst to speed up the reaction, okay? And in this case, you really want to write down this yellow dot. Enzymes do not provide energy, but they lower the activation energy required for a reaction. This particular bullet is a verbatim test question. So you want to make sure that you know that enzymes lower activation energy required for a reaction. Again, when raising the temperature isn't possible to make a reaction go faster, we can introduce an enzyme that is going to lower the activation energy so that you can make that reaction go faster. Again, if I want to start running and I want to be able to do it more quickly, my activation energy was that blue line. I can't raise my body temperature to 105, but I do have enzymes that can lower that activation energy so that I can get that reaction done faster. All right, enzymes are made of proteins, okay? You're going to need to know that for sure too. Enzymes are protein catalysts, so they're made of protein, okay? They're catalysts, meaning they're going to make a reaction go faster, and they bind to reactants. So you've got two or more, but substances, reactants, that are separated, okay, or a single reactant that the enzyme is going to bind to and lower that reaction's activation energy and allowing that reaction to happen faster. So you got an enzyme that comes in to those reactants, it attaches, and that reaction can now run faster to give you your products. Okay, enzymes are temporary, right? So your enzyme connecting with your reactants is going to not hang out forever. Okay, that enzyme is going to bind to the reactants, and then once the reaction is done, it releases the reactants, and then it can go and do another reaction. It's temporary. So it's going to bind to the reactants, the substrate, and then it's going to run that reaction and then let the reactants, and which are now products, go, and the enzyme remains the same and can go to catalyze another reaction. So enzymes lower the activation energy by changing the shape of the substrate. So basically when they attach, okay, when an enzyme attaches to the substrate, okay, it's altering the shape of that thing. So it's going to, if the shape of the substrate was originally here, enzyme's going to come in, change the shape, and then that's going to go away, okay, and makes a bond which causes the shape to change. Enzymes are super specific, right? We said this before. Each enzyme only bonds to a certain type of substrate. So one enzyme can't go and do like 50 different types of reactions. It's made very specifically for a specific substrate, a specific reactant, and it's made to only do that specific thing. So the example that you're going to hear a lot about, and this is also on your test, is that it is a lock and key model. So there's basically one lock and one key in an enzyme situation, right? So they fit together like a lock and key. So you've got the substrate and then the enzyme, and they fit together perfectly, and then they release. But that enzyme now can't go and fit into another lock, right? It's only specifically made for one. Enzymes are rapid, okay? They bind to the substrate, catalyze or start the reaction, and then they move to the next reaction. Again, this is a fast process. It's the reason that we have it, so that you can make those reactions go faster. If we didn't have enzymes to do these biological reactions in our bodies, it would take way too long to get all of the functions done that our bodies need on a daily basis. So they start the reaction, they catalyze it, lower that activation energy, and then release and move on, and so they can do that rapidly. All right, for enzymes, there are some requirements, okay? Enzymes only work in specific pH ranges, temperatures, and ionic conditions, okay? So they have an optimal operating capacity. For example, if you have enzymes that are working, okay, and they work well, the pH means if the environment is too acidic or too basic, okay, then that enzyme will not work. It will denature. Okay, so if the enzyme is in a too acidic or too basic environment, it will not work. If it's in too hot or too cold an environment, it will not work. And then certain ionic conditions, if you have too much of a certain atom, or in for your guys' brains, a certain chemical in your body, then they will not work, okay? They're kind of like somebody who wants to be comfortable all the time in only their comfort zone, and they will never leave it. That is what an enzyme wants to do, and it will not work. It's not like it can choose to. It will not work if it is not in those optimal conditions. So any extreme, like if it's too hot, too cold, too acidic, too basic, too much salt, not enough salt, all those kinds of things, it will destroy the enzyme. And the word that you need to know is this word denature. Denature means to destroy. If it gets into a too hot environment, okay, it will become denatured or destroyed, and that enzyme no longer exists, okay? And when a protein denatured, it will not work. All right, in the energy portion of what we're talking about with enzymes, reactions give off or require energy. So if you need energy for a reaction, or you're going to give off energy for a reaction, okay? Every time we have a reaction, we're either using energy to power it, or it goes through and it's giving off energy. Again, the energy that we've been talking about with enzymes is activation energy, and that's the energy needed for a reaction to start. Okay, again, activating the reaction. It needs it to start. A catalyst is a substance that speeds up reactions by lowering that activation energy. Again, think of that chart. Okay, the blue line is what would be normal energy needed, but if we add an enzyme, we can bring that energy down to make it easier and faster to run that reaction. Enzymes are biological catalysts made by the cell. I know that this particular point right here, that enzymes are biological catalysts made by a cell to speed up chemical reactions, that is on your exam. Almost 100% sure, okay? And enzymes are proteins. This is an example of the lock and key model. So this is giving you a picture of what an enzyme and substrate looks like. It's not real, like this isn't a perfect picture of what happens in your body, but it is a rendering of how you can think about it. So if you're looking at an enzyme, okay, we have the enzyme down here, and this is the substrate. Okay, this is the substrate, the reactant. It's what the enzyme is acting on. All right, so you get a shape for the enzyme that perfectly matches the shape of the substrate. This is why we're saying it is a lock and key model. If you get a different substrate that's a different shape, it's not going to fit in here, and that enzyme is not going to be able to run that reaction. So the enzyme and the substrate relationship is like very specific. And then when you have both of them put together, and you need to know this, okay, when they are both together like that, put together in that lock and key form, and they're together and the reaction is running, it's called the enzyme substrate complex. So there may be a question on your exam that deals with this. So you need to know when the enzyme and the substrate come together, that's called the enzyme substrate complex. In summary, you want to make sure that you just go back and reflect on your notes. Think about all that stuff in your left column, make your connections. So do your points on the left on your Cornell notes. And then the summary at the bottom of the page, just make sure that you write that summary of that page for you. And then your notes obviously won't go in a Google Classroom. They will stay in your notebook. So that is enzymes. Hopefully you got what you needed and can start working. See ya.